Today's internship topic is identification of the most significant feature which causes attenuation and lag in the routing of flood hydrograph. Prerequisite of this internship program is number one, concept of flood routing. Second, what is attenuation? What is lag? And what are the factors that affect attenuation and lag? For this, to kindly refer to my lecture on attenuation and lag. I have added them at the end of this lecture, and also mentioned them in my description of this video. Flood routing, there are multiple videos where I have lectured about flood routing. For the factors, yes, this attenuation and lag can be affected by various factors like the characteristics of the storage structure, also not only the storage structure but also the spillway and also the outlets connected to that storage structure. Correct? So basically these three and capacity of storage. Characteristics of storage structure, spillway and outlet, and also the capacity of storage controls the attenuation and lag. And when it controls the attenuation and lag, it also controls the flood routing. As you know, flood routing is nothing but the estimation of outflow hydrograph from the inflow hydrograph, which has the potential to cause flooding in the downstream. Okay, and by attenuation and lag, certainly when flood hydrograph is or rather a flood is entering into a reservoir, then what happens? Due to the storage capacity of the reservoir, some amount of water gets stored. So the amount of peak flow in case of inflow hydrograph, that is the inflow flood hydrograph, and the amount of peak flow in case of outflow hydrograph, that is the hydrograph that is going out of the storage structure, is different. And also the outflow peak will be lesser than inflow peak because water is already stored now. And due to this storage structure also, the time of peak of inflow and outflow hydrograph is different, certainly. as there is a storage structure, there will be a time lag, because that storage structure will store water, and when it stores water, it is somehow resisting the flow of water. So when it is resisting the flow of water, certainly the time taken to reach peak flow in case of inflow hydrograph will be much more when it will be much more at the time of outflow hydrograph, when it is trying to reach peak flow. So this time difference between the peak flow of inflow hydrograph and peak flow of outflow hydrograph is known as lag. Okay, so this attenuation and lag is controlled by characteristics of the storage structure, certainly. Not only storage structure, also the spillway, outlets, and also the capacity of storage structure. Now, by characteristics of storage structure, I mean, yes, what do I mean? The first thing is the geometry of the storage structure. 2, the amount of sedimentation already available in the storage structure. 3, the geophysical characteristics of the storage structure. 4, infiltration capacity of the storage structure. 5, evaporation. And yes, if some excess rainfall takes place, then that will also take place. But evaporation and precipitation is not under characteristic of storage structure, rather characteristics of the location of the storage structure. So if we assume that this we will not consider, then let us not consider this, but we will only consider the characteristic of the storage structure. And yes, spillway, outlet. In case of spillway also, geometry is a factor. How much amount of sedimentation is there, that is a factor. Geophysical characteristic of the bed of the spillway is a factor. Infiltration is also a factor. Okay, so not only these 4, there might be many other factors which represent the characteristic of these structures. And also another thing is that the capacity of the storage. If the capacity is more, the characteristic of outflow hydrograph will be something which will be different when capacity of the storage is less, certainly. And by characteristic of outflow hydrograph, I mainly indicate attenuation and lag. Okay, so not only capacity of storage, also number of spillway or number of outlets. These will also this also has a role in controlling the attenuation and lag of the outflow hydrograph. But the next question comes is, which among all these factors is the most significant one? Okay, which one is the most important? There is a most important role in controlling attenuation and lag. Not all the factors have the same role. It cannot be. But within these factors, there are some factor 1 or 2 which has the maximum impact in controlling the attenuation and lag. Identifying those factors is the goal of this internship. And how you can do it? By using an objective equation developed for this, and by using that artificial hummingbird algorithm and the gray wolf optimization technique to optimize that equation to find the best solution. So what will be that equation? Let us see. So here we'll try to model peak flow of the outflow hydrograph. As I have said, flood routing is nothing but estimation of outflow hydrograph from inflow hydrograph, which has the potential to cause flooding in the downstream. That is what is flood routing. And all this explanation that I am giving is for level pool routing. That means when the storage structure have a surface area which is leveled. Okay, so level pool routing. That means the reservoir routing or spillway routing, this type of routing I am talking about. So this QP, you see, is a function of geometry G, sedimentation S, GP, geophysical characteristic GP, infiltration I, capacity C, these all for the storage structure, main storage structure. And similarly, the same parameters can be found out for spillway. This is for spillway. And another will be for outlet. Right? Okay? And let me say the capacity. Yes, capacity CS. And spillway capacity will be CSP. Outlet capacity will be CO. And the number of spillway, number of outlet, just multiply N for spillway, M for this outlet, indicating the number of spillway and number of outlets available. So this peak flow is actually the function of all these parameters. Now let us use a decisive variable, or rather let it say a design variable W. This W is used for each of the parameters. That means W, 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 for all there will be a separate W. Here also W. This W will multiply with the G. This W will multiply with the SS. Okay? And this W can be equal or different. But they are nothing but some random numbers. Okay, now let us say we can make an equation like this: QP predicted is equals to the W's X and say V X. V is number of factors, right? 1, 2, 3, 4, 5, 6, 7, 8 and so on. All the number of factors. They are all represented by V. That means actually V is geometry, V is sedimentation, V is this geophysical characteristic, V is infiltration, all this. And you multiply this like this. That means summation of the product of the W's and the factors. And these factors are actually the magnitude of the factors of a certain location. Uh, we assume that this weighted summation will give us the peak outflow. Correct? Now, here this W is assumed to be a random number in between 0 to 1, and a random number in between 0 to 1. That means any real number in between 0 to 1, but never equals to 0, never equals to 1. And is randomly generated at each iteration. And we'll consider these V's to be the magnitude of the factors for that location, for the selected case study locations. Right? That means the geometry of that location, geometry of storage structure of that location, geometry of spillway of that location. So this is your predicted QP. Now, if I know what is actually the peak flow of the outflow hydrograph, then Q minus QP predicted, let me indicate it by YP is equals to Q. This is the actual outflow, peak flow of outflow hydrograph of that location, minus the predicted peak flow of the outflow hydrograph of that location, which is being equals to the product of the weightage multiplied by this magnitude of all the factors which controls attenuation and lag of outflow hydrograph. And if you consider this as the objective equation, and if you consider this W to be the design variable, and if you use the if you constrain these W's in between 0 to 1, then by using your artificial hummingbird algorithm or this Gray-Wolf optimization technique, you can find a solution where the difference between Q and QP, Q is the actual, QP is the predicted, the difference between the two will be 0 or nearest to 0. Okay, so when that is achieved, that is our objective of our optimization problem here. At that juncture, if we note down the values of the weights, this W, which we consider as design variable, then that weight will give us the most significant factor, which will be none other than that factor which is multiplied with the weight having the maximum value among all other weights. But you are multiplying the weights with all the factors now. And when after optimization at the juncture when Q minus QP is minimum, that means nearest to 0 or 0, then at that juncture one of the weight will be maximum compared to all the other. So that weight and that factor which is being multiplied to that weight will be the most significant factor among all the factors of all the factors that control the attenuation and lag of the outflow hydrograph. So this is just the brief of the internship. I am giving just the overview of it. If you join this internship, then you, after doing this problem, after solving this problem, you will understand whether really this method can identify the most significant factor which controls the lag and attenuation of outflow hydrograph. So if you want to join my internship, you just give a comment to this video and then I will give you the necessary instruction to join this internship. And remember, this is an offline internship, it is not an online internship. So you have to come to my institute and do this internship. But yes, you can complete this internship within 1 month. Okay, so with this I finish this video. If you like the internship, you give the like, and if you are interested to join, kindly give a comment. Thank you and goodbye.